Hi, I will go through my code. First, I will restart kernel and run this application code. As long as this is running, I will go through the network Python file. The first task in our homework is to create the loss functions, the evaluation matrix. So accuracy is just use the correct count, what is already calculated before, divided by the length of test data divided by n. And then we calculate the MSE and cross entropy from the given functions. Just notice here is a 2 norm, and this is y is a desired outcome, and this feed forward function of x that is gives our activation value. And notice here there is a 1 over 2n at the beginning for MSE, and there's 1 over n at the beginning for the log function for cross entropy and log likelihood. For the log likelihood is kind of similar to cross entropy, but it is just for the values when the desired output is 1, that's when I use the y times this negative log here, because if it is 1, then it gives a value. If it is 0, it goes to 0. And then we can return all those loss functions in the SGD function. We create the training, return the training results and the test results. Notice there's a early stopping if the training accuracy is larger than the given termination percentage. And also we have two lists record the history of the training loss of functions data and the test data loss of functions. And at the end, for the SGD function, we can return those two lists into one list. And right now we can see this application code is run pretty well, and there's no errors or warnings. We can see if we run the first single instance, it gives our results, and this is our the returns from the SGD function. And then if the termination percentage is 0.6, we can see get 0.66 accuracy, and if it's 0.8 for this errors 4 to 3 data, then it gives accuracy of 0.82 after 89 inputs. And also we can check our data for 427.3 network for the iris data set. We can see the termination percentage at 0.6. It is runs after 33 inputs with accuracy 0.66, and for the termination percentage 0.8. In this case, after 125 inputs, the accuracy is 0.8. All those results are matched to the true answers showing on the website. And for the actual credit problem, what I do is I do a random split 70-30 training test for the average data, and then run network for 100 inputs, 20 mini batches, error, the learning rate at 1, and then this is the results, and we can plot this visualizations for the loss function, and we can see all the three are kind of pretty much decreasing monotonically. For the log likelihood, there's a small increase at the beginning, but then it just go all decreasing. And we can see after 60 epochs, it kind of taper and decrease, kind of goes to taper off after 6 epochs. And for the MSE plot between training and test, we can see those two MSE curves are pretty much close together, so to each other. So we can see the overfitting problem is not so severe for this round of the training. That's it.